Okay, let's look at the log equations. So we're going to use the properties of logs we learned in the previous video to solve the log equations for x. Alright, so let's do that. Alright, so you have a log to the base b of x is equal to 2/3 log to the base b of 27 plus 2 times log to the base b of 2 minus log to the base b of 3, right? So left hand side looks nice, so I try not to change anything here. It's already pretty nice. But you have a whole bunch of logs here, so I'm going to try to simplify the right hand side using log properties. Alright, so first thing I would do is since you have 2/3 here, so 2/3 can be placed as a power here, right? So let's do that. Log to the base b of 27 to the 2/3. Oh, before we do that, 27 is the same thing as 3 cubed. So I'm going to actually rewrite 27 as 3 cubed, right? But we raise it to the 2/3 power, right? So that comes from this 2/3 right there. All right, and here, so same thing. Here is 2. I'm gonna put it as a power up here. So it's going to be plus log to the base b of 2 squared, right? Then minus log to the base b of 3. This is simple enough, so just leave it as it is. Log to the base b of 3, right? And then we can actually simplify here a little bit. I'm going to use a different color. Alright, so 3 cubed, raise it to the 2/3 power. We can multiply the powers together, right? 3 times 2/3 would be 3 cancels out, so 3 and 3 cancel out. So you actually have 3 squared, alright? So we have that. Then we have addition here. So addition can be written as multiplication. So you have a log to the base b of, all right, so remember this is 3 squared, 3 squared, all right, addition becomes multiplication inside, so it's going to be 2 squared, all right, minus natural log, log to the base b of 3, not natural log, log to the base b. Alright, then if you have a subtraction, we can write it as a division inside. So you have a log to the base b of, right? So we have 3 squared times 2 squared. Now divide by 3, right? So subtraction becomes division, right? So we can cancel, there's 3 there. And you have 3 squared, so one of the 3 cancel out, so we have that. Then this becomes log to the base b of, right, so we have a 3 left over, 3 times 2 times 2, so 4, 3 times 4 is 12, so it's a log to the base b of 12, right? So then compare. Log to the base b of x has to be equal to log to the base b of 12. So we know that x has to be equal to 12, right? So therefore, so we found the solution. X is equal to 12. Right? So that's the solution. All right. Let's look at the second example. All right. Log to the base b of quantity x plus 2 plus log to the base b of x is equal to log to the base b of 24. Alright, so we have two logs on the left hand side, so I'm going to put them together. So addition becomes multiplication inside. So you have a log to the base b of, right, we have to multiply quantity x plus 2 and x. So I'm going to go ahead and multiply. So x times x gives you x squared plus x times 2 gives you 2x, right, is equal to log to the base b of 24. Alright, so you have the same log with the same base, so we can write it as, alright, so the inside has to match, so you have x squared plus 2x has to be equal to 24, right? Then I would like to have everything on one side and 0 on the other side, so I'm going to move 24. I'm going to try to move 24 to the left hand side. We can do that by subtracting 24 from both sides, right? So you have x squared plus 2x minus 24 is equal to 0, right? Let's factor out, right? So we have quantity here and the quantity here is equal to 0. Since we have x squared, so we probably have x here and x there, right? So we have to come up with two numbers whose product is negative 24. So one of the number has to be negative. To make 24, maybe 4 and 6, try 4 and 6. Alright, then one of them has to be negative, but the sum has to be positive too, so it's going to be a positive 6 and a negative 4. Alright, so if you multiply negative 4 and 6, you get negative 24. Add negative 4 and 6, you get positive 2. So that will work out. Alright, so therefore we have two solutions from this equation. X equals 4. And from here, x equals negative 6. Right? Right, but we have to be very careful. Let's look at these, plugging these values into the original function. Put 4 here. 4 plus 2 is then log to the base b of 6 plus log to the base b of 4. There's no problem. But let's look at the negative 6. Right? If you try to plug in negative 6, you're going to end up here. Maybe this is an easy one to look. If you plug in negative 6, you have a log to the base b of 6, right? But remember that the log function only takes positive real numbers, so it cannot take a negative value. So therefore, x equals negative 6 cannot be a solution of the original equation. So maybe I should write a note that right here, right? Note, right? Negative 6 is not in the domain of this log function, log to the base b of x, right? So therefore, this cannot be a solution. The only solution is x equaled positive 4, right? So it's a little tricky at the end for the second example, but so this is how you apply log properties to simplify equations so we can find the value of x. All right, that's it. I hope that this was clear.